So, welcome everyone to my session refactoring large JavaScript code bases. Before we start, let me introduce myself super briefly, I promise. I am Michele. I work as a staff developer experience engineer at Nearform. I'm a Google developer expert and Microsoft MVP, and I come from Italy. I would like to know how many of you likes pineapple on pizza. Please be honest. Shame. No, it's not. But we can discuss this later if you want. To give you a couple of contexts around the fact that I'm talking about JavaScript, let me introduce my company, which I want to thank for allowing me to be there today, which is awesome. As I said, I work for Nearform. We are a professional services company, and we are specialized in Node.js and JavaScript development specifically. And we maintain like 8% of the global NPM packages out there, which are responsible for like 1 billion monthly downloads. So if you're using any NPM module, there is a high chance that you're using something written by us and maintained by us. So we are hiring all over the world for remote. If you're interested, of course, I'll be there for chatting about it. And one very last thing I'd like to self-promote a bit. I built a full text search engine while at Nearform. It's called Lyra, fully written in JavaScript, TypeScript actually. And if you're interested in learning more about distributed systems and full text search algorithms, I'll be around. And I'm hug ready, so whatever you want to talk about this, I'll be around. So that said, I wanted to talk about refactoring for a very simple reason. Actually, 3 simple reasons. Refactoring is damn hard. We all know that. Let's acknowledge this. But it's also necessary. Most of the time, it's inevitable. And sometimes it's also pretty useful. So these are 3 reasons why we should talk refactoring. So let me give you a couple of examples. And all the examples you're going to see from now on has been taken from my personal experience while at Nearform and other companies, especially since I've been working a lot on a very large code base, like 50,000 files, JavaScript files. And whenever we had to refactor something, it was incredibly painful. So I'd like to share with you the strategies we went through when wanting to refactor everything. Let's start from a very simple example. This is totally fine code working on node 14. So if you basically run a promise rejection on node 14, you will get this warning. And again, this is a warning. So it says, OK, no worries, this is working fine, but please know that from this next major release, this code will cause a process termination with a non-zero exit code. Pretty scary, right? So if you try to run this code on node 16, of course, it exits with a 1 exit code. The process is terminated, and it's not good, especially if you have a very old JavaScript code base and you can't stay there, like try catching everything, looking for promise rejections, you know? So this is an actual example of how refactoring is necessary. It's not just useful, it's necessary at this point. Specifically thinking that if you go see the roadmap for the Node.js runtime, we see that in April 2023, Node 14 is going out of maintenance mode, and Node 16 will be still in, the one being maintained. But basically, you have 2 choices. Either you fix every promise rejection, for example, or you will have a great problem in process is terminating with a non-zero exit code. So this is something to consider, right? Let me give you another example. This is where refactoring is necessary. You can't avoid this. But I promise that there are times where refactoring is actually pretty useful. So let's go into that. Let's see the following code on node 12. OK? So who is using node 12 here? Let's be honest. OK. We will discuss this later. OK. It's out of maintenance mode, so it's better to upgrade. But apart from that, this is perfectly working code. So if you ever encounter this code in production, please keep it as is. This is perfect. I'm just explaining something for the sake of explaining stuff. That's really it. But we basically have an object where we have data, name, first and last name. And if we want to print the middle name, in that case, I don't have a middle name. So we basically null check against an object structure. And if we don't have a middle name, we just assign no middle name to the middle name variable. So when we console log this, we got no middle name, right? If you try to run this code using the optional chaining operator and nullish coalescing operators, you will get a syntax error, unexpected token dot. And that's because if you go here, let's see if it works. Yes, we have a question mark, and after every question mark until node 12, we always look for a ternary operator. In that case, we have a point. So that is not working on node 12, but it's working fine starting from node 14, all right? In fact, the exact same code, node 14, working just fine. Now, why am I telling you this? Because if you have a very old code base, there are chances that you are not actually running this code when you want to null check stuff, but you are running this. And while load-get, for example, it's an amazing software, so please, again, if you ever encounter this in production, this is not a problem. Let's keep it as is. But there are cases where, for example, we want to access a property that might be null, undefined, or not existing at all, and we basically use a get, we pass an object, a path inside the object, and a fallback in case the value does not exist. This is fine, but the problem I found many times in old code bases is that when you're using load-get, for example, which again, it's perfect, please don't remove it, but if you find this on an old code base, you're likely to use many other methods that are not really useful anymore. Let me give you an example. If you think of reverse, why don't I just use array.reverse? If I use isString, I have the type of function in JavaScript. Why should I use isString? Or like split, filter, map, keys. That made sense back when we had like ES3, ES5, so older versions of JavaScript where we didn't have that many methods to compute functional like code bases, etc. And again, it is fine, but please consider that if you're using a lot of this stuff on the front end, no problem. If you're using that on Node.js, for example, you're delegating a lot of computation to a third-party library, which means simply that you're spending much more time on computing your values, which translates in higher billing costs. So if you have a very large code base, this is costing you money. As simple as that. So at a certain point, you might want to refactor everything, removing all this stuff. And I have two ways of suggesting how to approach this problem, but we will get there. My problem is, again, as I told you, this is translating to loss of money if you have a very large code base. So how do we approach refactoring when we have such a large code base? So I have two approaches again. The first one is divide and conquer. And I'm sorry, we are going deeply into the project management side right now. Do we have any project manager here or product person? It's going to be super fun, yeah. So please consider, we will also get into the technical part, but this is pretty important, okay? So let's start with approach number one. Let's say we want to remove all the load-get methods, okay? We will start by dividing the code base with code owners. Are you all familiar with the concept of code owners? How many of you are using code owners? Okay, great. So let me explain for the other people who never used that what it's about. So if you're using like Atlassian or GitLab or GitHub, you're likely to use this file, which basically explains how to divide a code base. So let me give you an example. Let's say we have a design team or a front-end team, packages, design system. So it means that inside your monorepo, for example, every time you touch something that it's inside the packages/design system code base, you will need to at least, let's say, 1 or 2 approvals for from a member of front-end team. So that, let's say, the front-end team is the expert in the whatever regarding front-end. So every time you make a pull request that is touching something regarding front-end, you want them to approve that pull request. The same, for example, for QA. So test at Cypress at whatever file. Every time you touch something, John Doe or Jane Doe has to approve that pull request. So that's really it. First step, you divide everything into code owners. Then we say we want to remove load-get, for example. So we create or install linting rule at a warning stage. Let's say in 3 months, you will be blocked. So you won't be able to commit your code if you're not removing, if you're working on a file that has load-get without removing it. So if you're working on a file, you have load-get, you'll get an error saying, please, I know this is out of scope for your PR, but please remove this load-get import and refactor it using optional chaining operator, for example, at a warning stage. After 3 months, we introduce an error stage. So you won't be able to commit anymore, and you can do that with, for example, Husky or any other commit hook library out there that prevents you from committing stuff without actually fixing a problem, which can be a linting problem or a performance problem, whatever. In that case, it's a linting problem. Then there are parts of any large code base that no one wants to work on, right? Parts that are scary, parts that who knows who wrote this stuff, right? So there is a high chance that there is a part of the code base that never went through a new linting process. So at this stage, we just assign that part to the code owners, and this is where code owners start to be important, you know? One very last thing. We run the entire the linting against the entire project, and we spot where we missed the Lodash-get imports, for example. And again, I'm sorry, Lodash, I didn't want to do that to you, but I just needed this example, you know. So this approach, to me, has pros and cons, and this is actually an approach we had when I was working in another company on a very large code base, and had pros and cons. So first pros are that we ensure correctness. So every time I commit something that it's not in my comfort zone, let's say I'm a backend developer or whatever, and I touch something regarding like front-end stuff, I will need an approval from the front-end development team. It also allows you incremental adoption over time. So it's not something we need to get fixed like right now, you know. So it can take time, like 3 months, 6 months. We have time for that. And everyone is responsible because everyone is a code owner. So everyone can tell their opinions on the PR you made. And it's future-proof because given that it's taking time, it will be possible for every developer in the company to understand how to code and what problem we are going to solve. So people, it's unlikely to reintroduce Lodash-get after an entire company tried to get rid of it, right? Hopefully. And of course, this approach has also cons, which again requires time. So if we want to go in production with Node 16 like next month, this is not a suitable approach, of course. It also requires a great team effort and needs someone to coordinate everything. So project managers, again, and I'm sorry for them because it's not very fun stuff. But at this point, I'd like to go down the rabbit hole introducing an English, it's really hard for Italian people. I'm sorry for that. We want to automate everything, OK? So let's say that. We want to automate everything, and for that reason, I want to introduce codemods. So this is the second approach and the hacky way, OK? When we talk about codemods, we usually refer to a library. There is a tool written by Facebook to basically run code modification on large code bases based on regex. How much of you loves regex? OK, great. Oh, better than I thought. OK, that's awesome. We won't be talking about regex, sadly, but I'll be around if you want to talk about that, of course. Facebook originally created the codemod instrument, which is a Python library, if I remember correctly, to run, for example, if you go see that code, you go into the 3W library, look for every single file that has the extension PHP and HTML, look for the first regex, and substitute with the second one. Okay, so this is how it works. But it's not really performant. It's not really simple to use, especially since then we also have like JSX, which is really complex to parse using regex. So it's not really convenient to me. And they thankfully recreated a completely new library called JS CodeShift. JS CodeShift is a complete JavaScript library, which is free and open source for everyone to use, which basically allows us to interact with the compilation process for our code. Let me try to tell you what that means. So every time you need to compile JavaScript, which means compile from TypeScript to JavaScript, from ES6 to ES5 version, whatever, you have to go through 3 simple steps, which are not simple. I don't know why I say that. So you have to parse the code, you have to transform the code, you have to generate new code, okay? JS CodeShift will allow you to interact with that part of the process specifically, so the transformation part. So let's go down the rabbit hole for a minute about what does it mean to parse, transform, and generate code. So first step of parsing. We have to tokenize our code. So we have like an input, var foo equal tens, and we separate every single token into multiple tokens. We don't care if the tokens are in a right order. We don't care if are valid tokens. We just separate into different tokens. In the case for JavaScript, separated by space. That's really it. Then we create a parse tree. And when I say we, actually JS Code Shift is doing that for you, of course. A parse tree ensures that the syntax for the program is correct. And this is also called concrete syntax tree for a simple reason. You can still understand the meaning for the program by looking at the tree, which is not true anymore when we go into the next step, which is step first for syntactic analysis on the code, where we create an abstract syntax tree. And let me show you in that way. So we have like a variable declaration, which is foo equal 10. Inside the variable declaration, we have a new node called variable declarator, where foo is equal to 10. We have an identifier, which is foo, so the variable name, and a numeric literal, which is 10, and this is the variable value. Of course, if we had a string, it would have been like a string literal, or an object, or an array, or whatever. Of course, when you're working with JS Code Shift, you're not working on a good image that someone from Italy made. But you're likely to work on a scary JSON representation of an abstract syntax tree, which is basically a binary tree. And it's super, super scary, right? It's not simple stuff. But this is where JS Code Shift shines, in my opinion, because you don't have to manually traverse that tree, because tree traversal, we all know that it's not the simple stuff in computer science, right? But let's imagine you are in that situation, and you say, oh my God, I have to change that variable name, and I have to traverse an entire tree. How do I do that? OK, it's pretty easy, actually. So let's say we are looking for every single variable declaration that has the old name string inside the variable name. So we basically go here, and we start saying, OK, we take the J, which is like jQuery. It's a very bad coincidence. But yeah, we basically read the file and say, OK, please give me all the variable identifiers. So I will pass the entire source file to the J, what is the name? OK. J file source, we pass the entire source file here, and then we say, OK, find every single identifier. And for every single identifier, if the identifier name includes old name as a string, we just go to J identifier again, take the path, and replace old name with new name. And then we use the toSource method to print everything again back to the source file. And it's pretty easy, actually, because at this point, you might have like old name factory, which gets refactored to new name factory. So it's pretty easy. Of course, this is pretty trivial. Let me give you another example. Let's say we have a React code base, and we want to remove my header component, OK? So as you can see, we need to remove it from the import statement, but also from the JSX. If you want to do that manually, good luck. I will never do that again. I already tried once, failed, and used JS Code Shift for a reason. But let's see how to write a parser for that. It's pretty easy, actually. Again, we create a new constant call without element, where we basically say, OK, let's take the entire source file. Let's find for every single JSX element. And for every single JSX element, if the element name is equal to my header, which is the one we want to remove, we use the path, which is the path for the what's the name? For the object representation inside the abstract syntax tree. We just prune it, so we just remove it. All right, and then to source, so we rewrite the source code again. Then we have to remove the import, for example. So again, find all the import default specifiers. If you have like destructured imports, you use the destructured import identifier. So you can always choose. And for every single import default specifier, if the local name is equal to my header, we just prune it again. So, oh, sorry, too far. So that's really easy, right? And I mean, it's easier than going through an abstract syntax tree by hand. At least that's my opinion. You can be brave enough to try. But learning how to deal with abstract syntax trees, it's actually pretty important. Because let's say, at the beginning of the talk, almost 20 minutes ago, oh my God. OK, at the beginning of my talk, I said, let's say you want to remove load-get. So you have to create a linting rule. I tried to find online like a linter rule to remove load-get. I couldn't find one. But I learned that while working on abstract syntax tree, it's pretty complex. Every single tool out there that has to deal with code, especially JavaScript, because we have many good libraries in JavaScript, but basically they all give you the same pattern, which is called visitor pattern. So let's take an example. Let's try to create a linting rule that says you shouldn't use template literals, okay? So we basically do, instead of looking for template literals, we just say this is a ESLint plugin. So we say every time you encounter a template literal, please send a report, which means send a warning, a message, an error, whatever, where the message is do not use template literals. We can also try to provide a fix. So we can say, OK, we can also fix that, like with prettier, for example. And if we have any expression inside the template literal, like let's say 1 + 1, of course, we cannot replace that with double quotes or single quotes. So we just return. We won't fix anything. But if there's no expression, we just replace the first backtick with a double quote and the last backtick with another double quote. So we can also provide fixing. And this is why it is so important to understand how to deal with abstract syntax trees and how the visitor pattern works. I want to give you another example, which is from TTypescript, which is an awesome library built to interact with the compilation process for TypeScript. And this is brilliant, if you ask me. In that case, OK, this is pretty dense, so I'm going to just describe this to you. We basically say, if we find any binary expression, for example, 1 + 1, 10 + 20, every time we find a binary expression, if on the left side, 10 + 1, so 10, it's a number. And on the right side, 10 + 10, again 10, it's another number. If we are in that situation, why should I compile 10 + 10? We just compute that addition inside our compilation process, and we'll print the result directly in the source code obtained by TypeScript, such that we come into that situation. We have const mySound 10 + 20, and the output in JavaScript will be 30. Now imagine how powerful this could be when doing like asynchronous requests that only are meant to do during the compilation process, etc. We can do a lot of stuff. I'm not advocating for that, but we can do a lot of great stuff, I guess. Now it's time for a little demo, and I'm pretty scared. We'll see if we can get there. I promised you that we would get rid of load-get. So let me give you this simple example. This is an amazing website, which I forgot to open, so I'm not doing a demo. Next time, I'm sorry. Which is basically called estexplorer.net. It will divide the entire screen into 4 different sections. On the first section, you will have your input. So you have import get from Lodash, for example, which is something we want to get rid of. And then we also have the utilization of that library. So as you can see here, we have abstract syntax tree navigator on the top right side, a custom JS code shift rule here, and the result. So that if you find yourself stuck in trying to understand how to get rid, for example, of load-get, you can just use that website without installing anything on your machine and test it out. I take the code from this repository, so if you're interested in learning more about how it works to deal with codemods, this is an amazing source for you to follow. I would highly recommend you to look into that. And specifically, if you want to learn more about how to write great code mods, I will also recommend you this repository, Awesome Codemods. Here you will find a lot of great and beginner-friendly code mods to get started and try to understand how to write your own code mods again. OK, so far, we've seen 2 different approaches. We saw the pros and cons of the first one, which is the project manager way of dealing with stuff. And of course, we also have pros and cons about this one. So one pro, in my opinion, is that running JS code shift code mods, it's very, very quick. It's really convenient because you only need like one person, less team effort. You need one good computer scientist or like a programmer, a great programmer, and you go there, and in one day you can get rid of load-get on a 50,000 files code base. it won't affect other teams directly. So if you have different teams that are working on different stuff on your code base, they won't be affected because you just have one commit, refactoring everything, that's all you need. But of course has other cons, requires good computer science skills, which I don't have a computer science degree, so believe me when I say that everyone can get there, don't worry. But you need to study a bit how to interact with an abstract syntax tree, which sometimes can be a bit difficult, I would say. And tests are absolutely needed. Don't even try to run codemods without a good unit test suite. Like 99% of coverage, it's fine. 98, it's not fine anymore, because in that 2% percentage of uncovered tests, you will find everything that will ruin your code base forever. Believe me, I've been there. I'm a destroyer of code bases, so I know. And of course, QA, so quality assurance, is a must. You don't want to trust your own unit test. You want people to actually test your code. This is mandatory, in my opinion. And talking about personal opinions, it's my opinion again that JS Code Shift is good when you have like little distributed teams, because little distributed teams are unlikely to talk a lot to each other, so might be a bit difficult to organize in the project management way. If we think, for example, of the promise rejection problem we saw at the beginning, can you remember when we had like a promise rejection that will cause non-zero exit code and a process termination on node starting from node 16? I think that JS Code Shift it's not a good way for dealing with that for a simple reason. If we have a promise rejection, we want to understand why it got rejected in first place, and we want to deal with the rejection maybe with a backup strategy to remake again the asynchronous call, I don't know, or to connect to a database or whatever. So you don't want to automate everything in that case. You want to take care of your errors and make your application more resilient, etc., etc. And of course, if you really need something to get done quickly, approach to it's fine. You just automate everything. And yes, this is what I was talking about. If you're writing a JS Code Shift and this is what you get in return, this is pretty bad. I mean, what's the purpose of try catching everything? I remember one time I had a colleague that showed me that, is there anyone writing software for Android here? So can confirm? Okay, good, so no one will confirm this. I was talking with a colleague in my former company. He was writing software for Android, a very old version of Android. He told me, you know, I don't really care about rejections and crashing, exception, etc., because in Android, again, a lot of time ago, you can wrap the entire code base inside a try-catch, which has top priority. What the hell? Oh my God, this is so bad. You can't expect this to be a good behavior, right? And this is why I think that sometimes human intervention when it comes to refactors is absolutely needed. And this is an example of what I mean. I mean, if we have an API that it's, I don't know, it's failing for some reason, we might want to log something so that we, on CloudWatch or something similar, we know what's going wrong, where it's going wrong, and why. And then we have like we spawn a connection error, a retry backup policy of any kind. This is what we want to do. Yeah, I repeated myself. Okay, it's not just about JS Code Shift, of course. There are many different tools that can help you with smaller refactors, because let's be honest, sometimes JS Code Shift can be a kind of an overkill. And when you work, for example, with WebStorm or IntelliJ IDEA, which has also an amazing tutorial online on how to refactor JavaScript using their IDEs. I'm not paid for saying that, I promise. But this is an example of how it works. You don't basically have to write a JS Code Shift every time. There are IDEs that counts the references of a function, of a class, of an identifier, whatever, and has everything built in, of course, for driving that kind of large-scale refactors. Let me give you just another short example. You have all your key bindings, etc. So before diving headfirst into JS Code Shift, please make sure that your tools are not giving what you really need for driving a large-scale refactor, because there's likely a good possibility that you can do everything with your IDE. But we are developers, right? So we want things to be a bit more complicated than they should. If you're using VS Code, I can only recommend you this amazing plugin, which is called Abracadabra. And sorry, so people can take picture. Sorry, guys. Okay. So basically, again, it's really similar to the way that IntelliJ deals with large-scale refactors, and it basically helps you doing refactors on the entire code base. So again, please, I know we are developers. I know we want complex stuff, but sometimes we can just use tools written by someone else that are working fine. And yeah, exactly 30 minutes. So I'll be open for questions. Thank you all for participating. It has been an honor to talk here. Thank you.